we will solve some more problems on projectile motion. The first problem states like this: maximum range of a field gun is 2000 meters. If a target at a distance of 1200 meters is to be hit, what should be the angle of projection? See, it's a very simple problem. You know that in the case of a projectile motion on a horizontal plane, A is the point of projection, and suppose if B is the maximum range, so you can see that the projectile travels the trajectory of a parabola and hits the ground here. Now let me take that this is R max, maximum range. So in this problem he has given R max as 2000 meters. Now you have proved that maximum range can be occurred only if the angle of projection is 45 degrees. If the angle of projection alpha is 45 degrees, then only you can have maximum projection, maximum range. For example, the expression for range in general is R is equal to u square sin 2 alpha by g. This is the formula to find the maximum any range. If you want maximum value of this R, the sin 2 alpha should be equal to 1. So this all this I have proved. If sin 2 alpha is equal to 1, then R becomes R maximum, because the maximum value of sin 2 alpha is 1. So sin 2 alpha is 1 means 2 alpha will be 90 degrees and alpha will be 45 degrees. That means if the angle of projection is 45 degrees, then only you can have maximum range. Now he has given the value of maximum range as 2000 meters. Now let us use this formula to calculate u now. So R max is equal to now u square by d, because sin 2 alpha will be 1. When R is equal to R max, sin 2 alpha will be 1. So u square by d we are going to get. We have this as 2000 meters as given in the problem. So therefore, if you find out u from this, 2000 into 9.81, that is g under root. So you are going to get the value of u as 140.07 meter per second. 140.07 meter per second. That means this is the velocity with which the projectile has to be shot to get maximum range. Now, what we have to do here is, he has asked with what angle this gun or this bullet from the gun has to be projected so that it should hit a target. So I will take the target here, B dash, at a distance of 1200 meters. So here R max is 2000 meters. Suppose if the target is at B dash, which is at a distance of 1200 meters, with what angle? With what angle this projectile or the bullet, you can say, has to be shot? So we have proved this also. Suppose for a given range, here R is the given range, here R is equal to 2000 meters. You will be having two values of alpha. Two values of alpha, so that it hits the target. So it will be like this. So this I have proved in the earlier lecture. You can just go through that. So here, if A is the point of projection, if R is given here, B dash, I have taken B dash, this is given R, which is 1200 meters in this problem. This can be hit with two angles of projection. One angle will be like this, another angle will be like this, with two angles. So one angle is alpha 1, another angle is alpha 2. Another angle is alpha 2. Of course, with the same velocity. So this is alpha 2 and this angle, bigger angle, I make as alpha 1. Because you will be having sin alpha or sin 2 alpha one value. So you know that sin 2 alpha and sin of 180 minus 2 alpha will be equal. Therefore, you can have two values of 2 alpha. Therefore, you can find out two values of alpha. Now here, the question here is, which it is projected with the same velocity, 140.07 meter per second. Now, suppose if it is projected with the same velocity, with what angle it should be projected so that the bullet hits the target at a distance of 1200. So for that, once again I have to go back to the expression for R. The expression for R here is u square sin 2 alpha by d. Here alpha is unknown, R is known. U is known, R is known, alpha is unknown. Therefore, sin 2 alpha is equal to R into G divided by u square. Here R is given as 1200 meters, G is 9.81. Divided by u, we have calculated 140.07 square of that. So sin 2 alpha is equal to, if you simplify this, you will be getting 0.6. So this value will be 0.6. That means sin 2 alpha is equal to 0.6 means you can have two values of alpha. So 2 alpha can be sin inverse of 0.6. So sin inverse of 0.6, you will have two values. That is, one value is 36.87, another value is 143.13. 36.87 degrees, or it is 180 minus 36.87 degrees. So because sin 180 minus theta is also sin theta, so you will be getting the answer as 36.87 degree, or it can be projected with an angle of 143.13 degree. This is 2 alpha. Therefore, alpha is equal to half of that, 18.435 degree, or it can be 71.565 degree. Okay. So this is the angle with which the bullet has to be shot to hit a target at a distance of 1200 meters from the point of projection. So this is how we have to solve the problem. From the first data, R maximum data, we have found out u, and with the same value of u, with what angle we have to hit, we have to project so that it hits the target at a distance of 1200 meters. So it's a simple problem. Now the second problem which I am going to explain is, second problem, it is like this. The problem states like this. A stone is projected upwards. I will write the problem. A stone is projected upwards from the ground with velocity of 16 meters per second. From the ground with velocity of 16 meters per second. 16 meters per second at an angle of 60 degrees to the horizontal. At an angle of 60 degrees to the horizontal. So the question here is, with what velocity must another stone be projected? With what velocity must another stone be projected at an angle of 45 degrees? Be projected at an angle of 45 degrees to the horizontal from the same point to the horizontal from the same point in order to have the same horizontal range, that is one thing. And second thing is, in order to have the same maximum height, So of course this is also a simple problem, but you should know the formula to be used. So let us see, there are two cases here. Two stones are projected. One stone is projected at an angle of 60 degrees with a velocity of 16 meters per second. Another stone is also projected, but the velocity is not known. We have to find the velocity. But this from the same point, but it is projected at an angle of 45 degrees. There are two cases here. In the first case, it should cover, both the stones should cover same horizontal plane, that is R should be same. In the second case, both the stones should cover the same maximum height, that is H. Okay, so this is how the problem is given. Of course, it's a simple problem, so I will write down like this. Let me explain that with the two simple sketches for both the stones. For the first stone, angle of projection is 60 degrees, velocity of projection is 16 meters per second. For the second stone, angle of projection is 45 degrees, velocity of projection is not known. That we have to find out for two cases. So let me take the first case. In the first case, it is like this. This is the horizontal plane. So y-axis, x-axis. First stone, A is the point of projection. First stone is projected at an angle of 60 degrees. At an angle of 60 degrees. So first case is same R. Range value is same for both the stones. So first stone, it is projected with an angle 60 degrees. See, this is the value of R. R is this. Point B is 60. So this stone, first stone, is projected at an angle of 60 degrees with velocity 16 meters per second. So that means I will write like this. U1 is 16 meters per second. Alpha 1 is 60 degrees. This is for the first stone. For the second stone, range is same. Please note that same horizontal range has to be there. It is projected at 45 degrees. So it is like this. See, it should have same range, it should come and meet here only. But this angle is 45 degrees. 45 degrees. This is U2. So U2 is not known. U2 is not known, but alpha is 45 degrees. So given this condition, you have to find out the velocity of projection. But with what velocity? So velocity of projection of the second stone we have to find out. So for that we have to use the expression for R once again. We know that in the case of a projectile motion on a horizontal plane, range is given by R is equal to U square sin 2 alpha by D. This is the formula. Now for the first, here in this case, R1 is the range for the first stone, R2 is the range for the second stone. Since we have the same values of range, the given in this case, R1 is equal to R2. So this U becomes U1, alpha becomes alpha 1 for the first stone, U becomes U2, alpha becomes alpha 2 for the second stone. Now if I use this R1 is equal to R2 for this, so the equation becomes U1 square, R1 square, R1 is U1 square sin 2 alpha 1 divided by D. It should be equal to R2. R2 is U2 square sin 2 alpha 2 by D. So if you simplify this, D gets cancels. So U2 is unknown here. You can find out U2 using this. U1 square into sin 2 alpha 1 by U2 square is equal to U1 square sin 2 alpha divided by sin 2 alpha 2. Or if you want U2, it is root of this, that is U1 into square root of sin 2 alpha 1 by sin 2 alpha 2. So substitute the values now. U1 is 16 meter per second into alpha 1 is 60 degree. So it is sin 120 degree. 2 into 60 sin 120 divided by sin 90. Alpha 2 is 45, therefore sin 90. If you simplify this, you will get the value of u2 as, that is the velocity of the second stone for equal range. u2 you are going to get 14.89 meter per second. So the answer is 14.89 meter per second. That means if you project the second stone with this velocity 14.89 meter per second at an angle of 45 degree, it will have the same value of range. So if you observe, if alpha 1 is 60 degree, u1 is 60, alpha is 45 degree, so u2 is 40. That means it has reduced. The angle is also reduced, velocity is also reduced. So for the second case on simple lines, in the second case they are given same height and height is same. That means in this case what happens, the diagram will be like this. For the first stone, so A is the point of projection. For the first stone, let us say it has reached certain height like this. So the angle with which it is 16 meter per second and the angle is 60 degrees. For the second stone, it should have the same maximum height, but the angle of inclination is different. So angle of projection is different. So how to write that is, I have to take 45 degree, but it may go somewhere here. Somewhere here it may go. So let us say, that means in this case, it should have the same. It should have the same height. Height should be same here. So one is for the first stone, another one is for the second stone. So this is 45 degree. So in this case, what is the velocity u2? So please see the difference here. Here r1 is equal to r2. Here h1 is equal to h2. So maximum height reached in the first for the first one is h1. Maximum height reached for the second one is h2. Now range will be different. So let us write here that the expression for maximum height. The expression for maximum height of individual projectile h is given by, so we have derived that equation, h is equal to u square sin square alpha by 2g. So I will use that, u square sin square alpha by 2g. So you have to remember, in this case you have to remember the expression for range. This expression you have to remember. In this case you have to remember the expression for the maximum height. Since h1 is equal to h2, u becomes u1, alpha becomes alpha 1 for the first stone, u becomes u2, alpha becomes alpha 2 for the second stone. So I will write the expression now, h1. Now h1 becomes u1 square sin square alpha 1 by 2g is equal to u2 square sin square alpha 2 by 2g. So these two are equal, therefore 2g gets cancels. So if I want u2, so u2 is equal to u1 into sin alpha 1 by sin alpha 2, and I have taken square root both sides. If you take square root both sides, all squares will vanish. So this is the expression you are going to get. u1 is 16 into sin alpha 1 is 60 degrees divided by sin 45 degrees. Now if you simplify this, you are going to get the expression for u2 as, answer for u2 as 19.6 meter per second. 19.6 meter per second. That means if you project the second stone with a velocity of 19.6 meters per second, then it will have the same height, maximum height reached as that of the first stone. So this is a simple problem. Only thing is, here you should remember the expressions for range as well as maximum height, and you have to equate them for both these stones by taking h1, h2, r1, r2 equal.